Hello everybody, it's Mr. Roy. I'm going to be taking up the homework for section 7.5 Arithmetic series. So that's on page 452, numbers 3, 5F, 6, C, and F. So here we go, we're going to jump in. Our first one, this is number 3, it has to deal with bricks in a stack. So really this would be kind of like a pyramid-y looking thing, if you think about it that way. So on the top row, we're going to have 5 bricks like this. That's the best thing I've ever drawn. Way to go, me. And the next row has some extra number, right? We don't know how many, like something like this. We're not sure though. All we know is that this bottom row at the very bottom is going to have 62 bricks. And we're going to need to figure things out. So it's probably easiest if we consider this the first term and this our last term, because then we're starting with a smaller number and we're counting upwards. You could consider the bottom your first term and the row of 5 bricks at the top your last term, but I think it's probably easier, and the math would work out fine, but I think it's probably easier if we go from the top to the bottom. So the smallest row at the top down to the bottom. We're trying to figure out how many bricks are in that stack. So I'm just going to clean up my board, and then we'll jump in on this, solving this problem. All right, I got a nice clean board, so here we go. Let's first see what we know. How much of this can we translate into our normal math that we need to know? We say, okay, how many rows are we talking about here? Well, it tells us right in the question we got 20 rows, so our n is going to be 20. Do we know our first term? That's A. Sometimes we label that as T1, means the exact same thing, our starting term or our first term. We know that that's going to be 5 bricks. We Now you might next say, are we going to be doing a common difference or a common ratio, right? And that's a good question. But you'll see in the question it tells us about it. It says each row has a fixed number of bricks more than the row above it. So that tells me we're dealing with an arithmetic series. It's going up by the same number each time. It's not multiplying. We're adding the same number each time. So we're looking here at a common difference. So this is going to be D, common difference. And that one we don't know, right? Where it's not really given to us. It just tells us that there's a certain number more. We do know a couple of terms. We know the 20th term in our list of bricks, and it's going to be 62. There's 62 bricks in that 20th term, in that 20th layer of the stack. And we also the sum of all 20 rows. That we don't know either. And that's really what we need to figure out. So it looks to me like we should be able to figure it out if we can use our sum formula. So if we go to our sum formula for an arithmetic series, we say the sum of n number of terms is going to be n times 2a plus n minus 1 times d. I probably should have put a square bracket on there. And all that is over 2. So let's identify what we have and what we don't so that we'll know what we need to go and get. Okay, so we've got our n, we've got our a, we've got our n. So we're good, except for the d, right? That's the one we don't know that we're going to need in order to get the sum. Okay, well let's get this out of here and let's see if we can figure out the d value. That means how much it's going up by each time. So usually when we need to figure out the d value, we need to look at 2 terms and we need to compare how many steps it's taken in between those 2 terms. So we know on the first row we got 5 bricks. On the 20th row we have 62 bricks. So we need to figure out how many that's going to be. So let's see how many jumps there are between the first row and the 20th row. You might be tempted to say there's 20 jumps, but there's not actually 20 jumps because we start on the first row. We don't start on the 0th row. Right? So we start at 1 and then we count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's actually going to be 19 jumps. So we're adding our common difference 19 times. So if I go 19 times the common difference, That should give me all 19 jumps from term 1 to term 20. And then if we subtract the difference between the two terms, our 20th term minus our first term, that should give me all 19 jumps. So to get from the first one to the 20th, we have to add our common difference 19 times. Okay, so this is a thing you'll see in many questions where we're comparing two um, terms in a sequence, in a series, or no, in a sequence, yeah, where they're not next to one another. We're going to subtract two terms and then say how many times does the difference go in between them. So you're going to see this little structure that I've just done right here that I'm going to put this blue thing around. You're going to see that come up in a lot of problems, okay, if you're not given the common difference or given numbers where you can compare that. Okay, so let's sub in some numbers to figure out what that is, right? We know there's 62 bricks in the 20th one, and there's 5 in the first one, and we have 19 jumps in between. So that's going to be 57 equals 19D. Divide both sides by 19. We're going to end up with D equals 3. Okay. So that means each section of this wall has 3 more bricks than the section above it. Now at this point, if you wanted to do the sum the hard way, you could say, well, the first one has 5, so that means the next one has 8, and the next one has 11, and the next one has 14. So I'm going to write out all of those numbers, and then I'm going to add them all up with my calculator. But that's not what we're shooting for, right? We're shooting to be able to use our formula to add things up. So now that we know that D value, we can use our formula. So the sum of all of those numbers up to number 20, we're going to use our arithmetic series formula. There we go. So let's sub our values in. So the sum of the 20 rows, we're going to sub in 20 for n. Our initial value is 5. For n minus 1, we're doing 20 minus 1. Our common difference is 3. Now our nice little shortcut, let's cross out the 2 and the 20 and change that into a 10. That's just a nice little shortcut, right? Rather than multiplying all that stuff on the numerator by 20 and then dividing it by 2, let's just multiply it by 10. So we divided 20 divided by 2 is 10. Okay, let's simplify this a little bit more. We've got 10 times 2 times 5 is 10. 20 minus 1 is 19 times 3. Let's get ourselves a little more room here. Okay, 19 times 3, that's 57. So we end up with 10 times 67. That's going to be 670 bricks. So we'll say, therefore, the wall has 670 bricks. Okay, let's do a quick little recap of what we did to solve that. We wrote down the stuff we knew and the stuff we didn't know. We looked at our formula for summing things up and recognized that in order to be able to do that, we needed the common difference D in our formula. To find the common difference D, we said, well, we know 2 of the numbers in this sequence, so let's subtract those 2 numbers, and then that would tell us how many jumps we'd taken to get from one to the other. Turns out it's 19 jumps, not 20, so be careful there. Subtracted the 2 numbers, divided by 19, and we found there were 3, the common difference was 3 in between each of them. We subbed it into our formula, and we got our final answer. All right, let's move on to a really tricky one. For each series, calculate the 12th term and the sum of the first 12 terms. Okay, this is not a usual series. This contains some unknowns. So we've got P and we've got Q. Now, I want to kind of compare in between one to the next, and that's going to tell us a lot about this. So let's grab this and move it down just a little bit so that we can have a look at it and compare how these things change as we move from one item to the next. Now I notice my first term is p, so I'm actually going to write that in right now. My a value, which is also my first term, is going to be p. In this case, it's not a number, it is an unknown, and that's fine. No problem there, right? Um, let's see, is there anything else that I notice? I don't know yet if it's a common difference or a common ratio. Let's investigate, and then we'd know if it's a D or an R. So to get from term 1 to term 2, here's what we're going to add. I notice I'm adding 1p, because I started with 1 and now I got 2. And I'm also adding 2 q's. So I added 1p and 2 q's. And to get from term 2 to term 3, what am I doing? Well, I notice now there's 3p's, so I'm adding 1p and 2 q's. And to get from term 3 to term 4, I'm adding 1p and 2 q's. So recognizing there, I say I do have a common difference. It is p plus 2q. That's the common difference. That's how much is getting added each time. Okay? So I do have my first term, and I do have my common difference, even if they're a little different than I'm used to seeing them up here. Okay, now I do have to find the 12th term, right? That's what it's asking for, the 12th term. So I can't find the 12th term unless I have, well, I guess I could just keep counting these up. I could just keep adding 1p and 2q's all the way up to the 12th term. But that's the brute force method. Let's try using our general term to figure that out. So here we go. We'll say our general term is going to be our first term plus n minus 1 times d. Let's sub those values in that we have for our general term. Our first term is p. Our common difference is p plus 2q. Now we're going to need to multiply through the brackets. So that means we got to do FOIL, right? First outside, inside, last. This one's going to multiply that one and that one. And this one's going to multiply that one and that one. Okay, we got to multiply all those things through the brackets. Whew, that's tough. Okay, n times p is np. N times 2q is 2nq. Now, I didn't have to put the 2 first, but that's normally how it's written, that we put the number coefficient first. And the order of those really doesn't matter, but that's normally how we do it, is we put the number first. Oh, I got a negative term next, so I better erase that. Because negative 1 times p is going to be negative p. Negative 1 times 2q is going to be negative 2q. Okay, so I've subbed into my general term formula. Now I got to collect my like terms. Well, let's see. I notice I've got a plus p and a minus p. Those are going to cancel each other out. And so looks like I'm going to be left with the following as my general term. Looks like my general term is going to be np plus 2nq minus 2q. So, okay, great. I got my general term. Now I can sub in a 12 in anywhere I see an n. I can sub in a 12 anywhere I see an n. So to find the 12th term, I just put in a 12 anywhere there was an n before. Simplifying this a little bit, 2 times 12 will be 24. And now I can add my q terms together. I've got 24 q's, and then I've got minus 2 q's. So 12p plus 22q. That's my 12th term. I could have gotten there by just looking at my terms and adding 1p and 2q each time until I got up to my 12th term. This is a bit more of a sophisticated way of doing it though. Okay, so that's my first part. Now I have to find the sum of the 12 terms. Okay, the sum of my 12 terms. So when I do this, I'm going to use one of my sum formulas, but I'm actually going to go to a new page. So let's go to a new page, but let's take with us our general term. And let's also take with us our D and our A values. Okay. So let's use we could use any of our summing formulas, right, to find the sum of the first 12 terms. But probably the easiest one is the one that looks like this. It's got an n, it's got term 1 plus term n, our general term, over 2. Right? Because I've already got my general term, I can just sub that in. Oh, I should have brought that from the other page as well. Pardon me. My general term here. So let's bring that along for the ride. Okay. So I can just sub that into my equation. Okay. Now in this case, I'm trying to find the sum of my first 12 terms. So really what I can do is I can say, okay, that's going to be the first term plus the 12th term, right? Because that's what I'm subbing in for n. And I have the 12th term. It's up there. So let's finish subbing in a 12 everywhere we see an n. Our first term is p. Our 12th term is 12p plus 22q. All that is divided by 2. Let's make our lives easier and turn the 12 divided by 2 into a 6. So we got a 6 out front. Let's add up our like terms. We've got 13 p's and 22 q's. Then we got to multiply that 6 through the brackets. 6 times 13 will be 78p plus 6 times 22, 132q. Whew, tough one. But that's going to be the sum of our first 12 terms. Again, we could do that the hard way by writing them all out and then adding up all the pieces, but that's tough. This is a more sophisticated way of doing it. So there you go. That's how we find the 12th term and the sum of the first 12 terms. A real tough one. Let's move on to our last one for our homework review. This is number 6. We're trying to find the sum of the first 20 terms of the arithmetic series, where we know the first term and the second term. Now it's nice that it tells us this is arithmetic, right? That makes it a little easier for us. We know we're using our arithmetic sum formula. I know my a value, that's equal to my first term, that's 53. And I can get my d, my common difference, because I can look at the difference between these two. My common difference, if it's an arithmetic series, will just be subtract any two terms, the latter one minus the earlier one, and we should be able to get the difference, common difference between those. So we'll go 37, which is our later term, minus 53, our earlier term, and we should end up with minus 16. So our common difference in this case is negative 16. Looks like we go down by 16 each time. Our n value here is going to be 20 because we're finding the sum of the first 20 terms. So we'll say the sum of the first 20 terms. I'm just going to sub right into the formula at this point. We put a 20 where our n is, 2 times our a, which is our first term, that's 53, plus n minus 1, in this case 20 minus 1, times our common difference, negative 16. All of that over 2. Again, we'll make our lives easier. We'll take 20 divided by 2 and make it into a 10. Okay, let's simplify this a little bit. Got a 10 out front. We've got 106, which is 2 times 53. 20 minus 1 will be 19 times negative 16. Nineteen times 16, that's definitely one I need a little calculator help on. I know it's going to be a negative number, because it's a negative times a positive. When we subtract our two terms in the brackets there, we're going to end up with negative 198. And then we multiply it by 10, negative 1,980 is the sum of our first 20 terms in that sequence. So we can see that it starts out positive, but very quickly it goes negative, and so you're adding up a lot more negative than positive numbers.
Hey everybody, I think you probably heard a staff meeting getting started there. So I'm back. All right, we're looking at our number F. 7th term is 43 and the 13th term is 109. So we're going to write down what we know. We know that the 7th term is 43 and we know that the 13th term is 109. So we know those two terms, and that's going to allow us to figure out everything else we need to know about it. So we can say how many jumps are there between 7 and 13. You might be tempted to say there's 7 jumps. You got to be careful. There's actually just 6. So 6 times the difference between the two gets us from one to the other. So we're starting at term 7. We jump once to get to term 8, 9, 10, 11, 12, 13. Okay, so we got 6 jumps. We add our common difference 6 times to get us from one term to the next. So we're going to say if we take the 13th term and subtract the 7th term, the difference between those two is 6 jumps. So our 13th term is 109. Our 7th term is 43. So that's going to be 66 equals 6 times our common difference. So our common difference is 11. Okay, so we say, all right, now we know our common difference. We need to find the sum. So the sum formula means we also need the first term. Otherwise, we can't use it, right? Because it's in there. So we need the first term, and this doesn't give us the first term. Now, I looked in the solution set that's posted on Edsby that you can look at as well, and you may have. And they actually came up with a really nice, quick, and easy way to think about it. I'm going to show you a way that's a little more complicated that was my first instinct. So the textbook says, compute from term 1 to term 7. To get from term 1 to term 7, you have to add D 6 times, right? So that means term 1 is going to be term 7 minus 6 times the difference, right? So that difference to get there, if we subtract that off of term 7, we should be back at term 1. So that's what they did, and they found that term 1 is going to be 23. Basically, they subtracted 11 6 times to get all the way back to term 1. So that's a really great way of thinking about it. Here is the way that I did it that is certainly a little more complex, but uses kind of the general term formula to help us get there. So here's what I did. I said, okay, our general term for an arithmetic sequence is this, right? And so I know the common difference, and I know if I can calculate A, that'll give me the first term. So let's choose one of the terms. Let's say term 7, right? That's one of the ones we know. You could have chosen term 13, and that would work too. So since it's term 7, we're going to go 7 minus 1. And we know our common difference is 11. And term 7, of course, is 43. So this is what we're going to end up with. 7 minus 1 is 6 times 11. So now let's solve for A. Subtract 66 from both sides, and we end up with negative 23. So I use the general term formula to solve for A. The textbook and their solution set that you've got access to that's posted on EDSB said, here's a different way, subtract your common difference 6 times. From term 7, that'll take us back to term 1. Both work just fine. Okay, now we're going to need to do the sum. So let's get ourselves a little more room here on the page. And I guess I'll do that in purple. And I kind of have a lot more room here in the middle. So I think actually what I'll do is I'll grab all this beautiful stuff and I'll move it over here. And then I'm going to do it on the side. So we're going to use our formula to figure out the sum now that we have all this other information. So the sum of the 20th term, I'm going to jump in right on that. We'll sub in at 20 for our n. 2 times our first term, we know which is negative 23, plus n minus 1, so that's going to be 20 minus 1, times our common difference, which is 11. Running out of room here. All that is divided by 2. Let's take the 2 and the 20 and turn it into a 10. So we're going to end up with 10 times. 2 times negative 23 is negative 46. And 20 times 1 is 19. Times 11 is 209. So when we add those together, we're going to end up with 10 times, and what's in the brackets? 163 is what we get in the brackets. So we end up with 10 times 163. That's 1,630. That's a tricky problem. A lot of work to get there, a lot of moving parts. Very sneaky one, really tough. If I wanted to challenge you on a unit test, this is the kind of problem I might be thinking about including, because you really gotta come at this from, you gotta really think about what you know and what you don't know, and then do a little bit of problem solving. So this is a nice tricky one. Okay, so that's all the homework problems. Those are some nice challenging ones. I hope that's helped you, and I'm looking forward to seeing you tomorrow. Bye for now.